All right, guys, I think we're ready to start. If you experience any difficulties hearing me or seeing what's on my screen, just let me know in chat. Also, just to give you some general information about the webinar, it will be approximately 45 minutes long, and we'll have some time afterwards for questions and answers. Of course, I know that questions might pop up at any time, so don't hesitate to write them in the question section or in the chat. I'll actually prefer to have the questions in the chat all in one place. And after the presentation is done, I will make sure to answer your questions. I'll do my best to do so. All right, so let's get back to business. Let me start my presentation. All right, so first of all, my name is Konstantin. I'm one of the 3D artists working here for ChaosGroup in the ChaosGroup headquarters in Bulgaria. And we had a great event organized by our partners, and the BlueGFX event 2014 was super successful for us. There was a big interest, and a lot of people attended the event, but obviously some of you couldn't make it, and that's why we're doing the current demonstration. Basically everything that was shown there will be included in my presentation today. Yeah, again, if you have questions, just send them in the chat, write them down in the chat section. Right, and the topic of today's presentation will be VRAY for Maya. And you probably know that VRAY 3 for Maya was currently released, and that's what I'll be using throughout my demonstration. And in general, VRAY 3 was a really big update for us, so we have improved our software quite a bit, and we usually do that in the following way. Each new version of our software is beta tested for a really long period of time, and we usually have like a closed beta first, when some of the people from big studios and some of our partners are testing the software, giving us ideas and feedback. Afterwards, we are moving into public beta stages, when all the users can test our software and give us their thoughts. And basically, at the end of this long process, we're releasing the final version. And that was the case with VRAY 3 for Maya. But the cool part about this process is that we have the ability to base all our updates on our users' requests, our users' needs, and suggestions. And that was, as I told you, exactly the case with VRAY 3 for Maya. So each one of the updates has a specific reason to be included. And we have a big set of updates. Some of them are like smaller updates and features that address specific needs and that can fit nicely into a particular pipeline. And we also have updates which are really big and which will affect everyone's everyday work for sure. Usually, if I ask a 3D artist what's the most important thing when it comes to rendering, 9 times out of 10 he will tell me that the speed is the most important thing, or the performance, also interactivity. That's the first thing I want to talk about. So let me actually switch to Maya and show you what I mean. So throughout my presentation, I will use production example scenes. So I will not use simplified examples. I don't want to bore you with those. In my scenes here, you will see most of the effects you will usually use in a production environment. And since I wanted to compare the render times between VRAY 2.4, the latest available version of VRAY, and VRAY 3, I did the following. I basically installed the previous version of VRAY in Maya 2014 and the latest VRAY 3 in Maya 2015. And Here's the same exact setup rendered on the same computer today before the presentation using VRAY 2.4. All right, and what I want to point out is the render time here in the frame stamp. So this one took approximately three minutes to complete. So in order to compare the render times, I'll now just render using VRAY 3. And here it goes. So I'm still using the bucket renderer. You will see some of the cool new things that we have added in a second. All right, and even though the image is not complete, I can tell you that the rendering will go faster. So this one will be rendered much faster than the previous image. And there are three main reasons for that. The first one is that our developers went back to the core of the ray tracing algorithms, optimizing and organizing everything. And as a result, we got a really significant speed boost. On top of that, in VRAY 3, we have added something called use VRAY. And VRAY is a set of ray tracing kernels developed at Intel. And it's specifically built for ray tracing. And ray tracing is all that VRAY does. This means that activating the option will save you a lot of time, boosting the performance of your CPU. And of course, newer CPUs will be affected more by the VRAY option. Older CPUs will be affected less, but there will be always a difference. And the VRAY will affect also motion blur. And when the rendering gets to the final stages, you will see that VRAY will automatically split the bucket size, making the render region division size smaller and smaller as it goes, taking advantage of all the CPU power available, all the threads available till the very end. So you will no longer see the last bucket staying there and rendering for a really long time, while all the other threads of your CPU are sitting idle. So let me increase the font and show you that this image took 1 minute and 37 seconds to complete, compared to 2 minutes and 50 seconds with the previous version of VRAY. So it's almost twice as fast. And there is a slight difference in the noise pattern, but that's because of the core ray tracing optimizations that I was talking about. And the speed difference will vary depending on your setup. So in a more sophisticated situations where you're using brute force, the light has to do a lot of light bounces, the speed difference will be greater. If your scene is really simple and the light has to do just a couple of bounces, the speed difference will not be that obvious. Here's another example image that I rendered in advance. This one was rendered again with VRAY 2.4 for 1 minute and a half. And after that, we have this image rendered with VRAY 3 for approximately 1 minute. So the speed difference here is smaller, but it's still clearly visible. All right, and even though the rendering went quickly, I still had to wait for the very last bucket to complete in order to take a look at the image in its entirety. And it would be great if I can basically click the render button, see the whole thing right away, even if the quality is not perfect. That's the idea behind a new image sampler type, which is called progressive and which is available in VRAY 3. This one will change the rendering mode from bucket rendering to progressive path tracing. So basically the whole image appears right away. It's noisy in the beginning, but as time goes on, VRAY will improve the quality, and at the end you have a perfectly clean image that you can save and use. And the best thing about this engine is that it actually uses the production algorithms in order to do the calculations. This means that 100% of the effects available in VRAY and in Maya are supported by the progressive renderer. A second benefit of using it is that it's extremely easy to set up. So those are the options. of the progressive image sampler, you basically only have a maximum render time and a noise threshold. The maximum render time can limit the render time. This way you can render sequences. So if I specify 5 minutes, for example, VRAY will render for 5 minutes. It will save the frame and continue with the next frames from the animation. You can also play with the noise threshold. This value will limit the quality, and with it you can actually render sequences with varying complexity and make sure that each frame, that all the frames have consistent quality. And another really great thing about the noise threshold is that it's smart. So if VRAY reaches the noise threshold in a particular area of the image, it will focus all the rays in another area which requires more rays. And this way VRAY is extremely adaptive while doing its progressive sampling. And on top of that, in case you're wondering, you can still use the optimized GI engines of VRAY. So right now I'm using brute force engines. That's why the image appeared right away. The GI was actually calculated during render time. But if I, let's say, switch to irradiance map and light cache or brute force, it doesn't really matter, and click render, VRAY will calculate the light cache first. It will do the pre-passes, and afterwards it will initiate the progressive rendering mode. So if you need to cache the global illumination in your particular workflow, you can still do it and take advantage of this engine. On top of that, as I mentioned, the progressive renderer is really simple when it comes to quality setup. The first reason is the small amount of options. The second one is that all the subdivisions in lights, materials, and other sections of VRAY are actually ignored. So it doesn't matter how many light subdivisions I specify, the progressive renderer will always finish with a nice high quality image. All right. And of course, you might be wondering, well, the progressive renderer looks similar to VRAY RT, because with VRAY RT, the interactive renderer of VRAY, you also start with a noise image, and after that the noise gets better and better till you have a clean image, and you also get interactivity, so you can play with materials, play with the lights or different properties of your set. Actually, to tell you a secret, in VRAY 3, the progressive algorithms are actually used for the RT CPU engine. So let's go to the perspective view, specify the CPU RT, and start the active shade. So we will see a similar image, but this one is interactive. So I can basically move the camera around, I can change angles, I can change the materials, I can change the lighting, the environment as well, and the image here in the frame buffer will respond right away. But the cool thing about merging the progressive engine and the RT is that now everything, 100% of the VRAY effects are also supported in real time, except for the GI, because the global illumination pre-passes, like the radiance map or the light cache, have to be done before the rendering starts, and they cannot be interactive. Everything else works just fine. This includes environment effects like the VRAY environment fog, also subsurface scattering, displacement, VRAY proxies, the complex blend materials, and the complex lights. All right, and if that's not enough, you probably know that with VRAY RT, rendering render elements was impossible before. And now in VRAY 3 we are changing that, and you can actually have render elements in real time. So this is the diffuse of my image, this is the reflections, the specular highlights, and even the render element like the light select works just fine using the interactive renderer. All All right. Of course, you can always use the render region option, and the follow mouse cursor now works in real time. So if I point at the area of my image, VRAY will focus all the rays in that particular area, leaving everything else noisy. This way you can use your mouse cursor as sort of a quality paintbrush, which is extremely cool. This way I can focus on the material of my of the armor of my character while leaving all the other parts noisy and not that clearly defined. All right, and when I'm talking about real-time rendering, I have to mention about some of the updates of VRAY RT running on the GPU. Because you know that with VRAY you have access to the production render, to the bucket render, the progressive rendering mode, to the CPU RT, but you can also switch to the CUDA version of our engine. And this one will initiate the real-time engine running on the GPU of your computer. So depending on your hardware, you can choose to work with the first workflow or with the second one. And you know that in VRAY, the RT running on the GPU was already a really powerful preview tool. So our users were able to use it in order to quickly set up the lighting, set up the materials, but they would rarely use it for production purposes. The reason for that were some limitations which were present in the GPU engine. For example, some of the complex materials, some of the complex textures were not supported. The lighting didn't appear exactly the same way. Render elements couldn't be rendered using that engine, and so on. Now in VRAY 3, we have dealt with most of those. So it's safe to say that at the current time, 90% of everything available is supported on the GPU. And if I start the CUDA version now, it will take a couple of seconds for VRAY to load all the assets, all the textures and the models required for this set to work. And then I can start interacting with my set, and my graphic device is taking care of all the ray tracing here. And you can see there's basically no difference between the image you saw before and the image you can see now. And that's one of the biggest strengths of VRAY. You can switch between biased and unbiased rendering, brute force or optimized rendering, CPU or GPU rendering, without changing your lights, without changing the materials, without changing the tools you use in your everyday work. And the results at the end will be basically identical. And if that's not enough, we actually have a full support for all the VRAY render elements, even on the GPU. So if I enable the diffuse, I can take a look at that in real time, the reflections, the speculars, global illumination, and so on. On top of that, the light selects are also supported. As you well know, the light select was already available in VRAY 2. It was letting you extract the contribution of a light or groups of lights, saving it in a separate individual render element. And then you can combine all the render elements in the post-production stage, rebuilding the RGB path and controlling the individual lights without re-rendering. The problem with the light select was that it was saving the diffuse contribution, the specular and the reflection contribution, but the global illumination was not included in the element, in the layer. Now with VRAY 3 rendered on the GPU, you have the lighting, the reflections, the specular, and the global illumination added to the mix. So you can do a full rebuild of your set and do a full relighting in Nuke, for example. Right, so let me actually stop the rendering right here. And I'll use the new VRAY shelf, clearly visible here in Maya, to reload my frame buffer. And I wanted to show you a second image. Here it goes. So here's another really cool character, again, rendered with all the light selects on the GPU. I pre-rendered that before the start of the presentation. So let me show you what you can do with that output in the post-production stage. So let me just open a set. Here it goes. So here I have the same scene rendered and loaded in Nuke. And this one was rendered with all the light selects. Each individual light source has its own light select layer. And at the end, I'm rebuilding the beauty pass. But this time, I'm adding all the light selects together. And of course, this opens up for really cool possibilities. For example, I can turn off or on some of the lights. But I can also do grading for lights or groups of lights like so. And the lights can even be animated here in Nuke without even me going back in Maya and re-rendering the whole thing. Here I did a really simple animation of those lights being turned on and off. And I'm relighting the set with full blown global illumination. All right. And now I will switch the topic a little bit, and I want to talk about materials. So we have some really big updates in terms of shading in the new version of VRAY, and I'll start by the VRAY OSL material. So what a lot of our users requested was a really easy and straightforward way to create their own shaders, to write shaders from scratch. And it was always possible with VRAY, but you had to do it in C++ and so on, and people found that really challenging at sometimes. That's the reason why in VRAY 3 we decided to add a full support for the open shading language through the VRAY OSL material and the VRAY OSL texture. Using those two nodes, you can actually write your own shaders using the open shading language, loading them here in Maya and rendering with VRAY. In my particular example, I wanted to create sort of a matcap shader like in ZBrush. So I wanted to have an image that will affect or create the shading data based on the angle of the surface and the camera, between the surface and the camera. So let me render and take a look at the result. So that's exactly the effect I'm getting. And it was really simple for me to write that using the OSL shader. And for the examples here on the right, I'm just using the matcap spherical map. For the example on the left, I have used the matcap combined with other VRAY material properties. Like in that particular case, I have an OSL texture that's affecting the model. But on top of that, I'm adding specular highlights and reflections in order to make this one look more realistic. And the best part about the OSL shader or the OSL material and the OSL texture is that you can combine it with other tools inside of VRAY or inside of Maya, creating more sophisticated results. All right, and as you well know, VRAY is a plugin available for a big number of base 3D applications. Like you have it in Maya, you have it in 3ds Max, Softimage, Rhino, Sketchup, and many others. And that's why we wanted to give our users a simple and straightforward way in order to transfer materials from one platform to the other, or even save materials in files that can be shared in between the different 3D platforms. And this new tool that was created is called the VRMat. It's a new material. And you can create VR materials in a couple of different ways. For example, I can convert existing materials to VRMat materials, or I can build them from scratch. Let's say I want to convert the material of my ground plane here in the set to a VRMat. I can open the VRMat converter from the VRAY shelf, I'll choose the ground material, set an output folder, and click Convert. Right after that, let me show you that. VRAY created this VRMats folder. In it, you have a subfolder with the name of the material and the VRMat file itself. The best part is that VRAY will actually find all the assets, textures, everything needed for the shader to work. It will copy them in the appropriate folder, and it will establish a dynamic link between the material file and all the textures. This way, if I load it in 3ds Max, I will automatically have it linked to all the textures required. After that, if you want to load the material, you can use the VRMat loader, select the file, and here it is. You even get a swatch in the Maya Hypershade. If I apply the material to the ground plane and re-render, you will see exactly the same effect. But this time, I'm not using the Maya material, I'm loading the VRMat from my desktop. All right, in case you want to change different properties of the material, you can click the button, show the VRMat editor, and this window will pop up. Here you will see all the layers, which are all the layers of the material itself. You can tweak the different parameters. For example, the subdivisions in order to control the quality. You can change the textures and alter the material in any way possible. On top of that, this material is currently a file on my hard drive. This means that I can have a single material library and use that material library in my mixed pipeline, like in Maya and, let's say, Softimage or 3ds Max. All right, so that's the VRMat. And another type of asset or another type of scene element that oftentimes needs to move around in between different softwares and platforms are simulation files. Like you can have volumetric simulations or also like liquid simulations which require surface rendering, and you need a reliable way in order to transfer the simulation or import the simulation from an external package. I know that a lot of people are using Houdini to create their simulations. They're using RealFlow and so on, but at the end of the day, they want to be rendering inside of Maya with VRAY. That's why in the new version of our software, we have added something called the VRAY volume grid. It can be created from the Create menu. If you go to VRAY, create VRAY volume grid. All right. This grid will let you load different files, and those can be OpenVDB files, filled 3D files, or even Phoenix FD caches. After the file is loaded, you can start rendering, and that's the effect you get. If I choose to work with VRAY RT, I'll be able to see the simulation in real time, and I'll be able to interact with its properties. Right, and another thing that is really cool about VRAY and that I didn't mention earlier is now you can have RT running in the viewport of Maya. You don't even have to use the VRAY frame buffer. So if I go to renderer here and choose VRAY RT, it will take a couple of seconds for VRAY to load the assets, and after that you will see the effect rendered in the Maya viewport. You can still select objects, you can interact with your set, you can even start modeling, and VRAY will be rendering and ray tracing all the time. In case you want to stop the render process, you just go back to your default viewport or the viewport 2 of Maya. This will stop the process. So with the VRAY volume grid, you can actually render the surface as a volumetric effect, or you can also change this one to ISO surface. And this way, VRAY will dynamically mesh, will create a mesh for this one, and we'll render it. So the volume grid actually uses the Phoenix FD, the Phoenix Fluid Dynamics simulations or capabilities in the background, algorithms rather. This means that each improvement that we make for Phoenix will be actually an improvement available through the VRAY volume grid at the same time. So that's something you get as a bonus. Also, it's really optimized really fast with VRAY. It's creating those ISO surfaces in no time whatsoever. All right, and another way of meshing, creating simulations and meshing them afterwards in VRAY 3 is something called the VRAY Metable. Let's take a look at an example. So here I have a set of particles emitted, and if I want to mesh them, I can actually create a helper called the VRAY Metable. It can also be created from the VRAY shelf, or you can go to create VRAY Metable. Then you establish a link between the particles and the helper, and the next time you render, VRAY will create a surface for each individual particle. But the best part about this surface is that it's not an actual mesh, so you don't have to worry about the quality and the curvature. This is a blobby surface, and the surface itself is created based on field mathematics. So those spheres or those meshed particles that you can see here will always be perfectly round and smooth, which is rather cool. They're rendered quickly at the same time. In case you want to see a preview of the blobby surface in the Maya viewport, you can always select the Metable helper and activate the preview. All right. This will let me see a preview mesh in the Maya viewport. So let me decrease the resolution a little bit, like so. And we have a lot of properties in order to control the surface. Like you have threshold, you have radiuses, you have the ability to smooth and apply different filters to the mesh, or even apply a texture that will alter the looks of the blobby surface. So using the same tool, I was able to create something like that. So in that particular example, I have a set of metables and a lot of particles. And all those particles are actually meshed during render time, or the surface is created during render time. And what you can see here are only the VRAY metables. So I don't have any geometry rendered whatsoever. I'm using different three-dimensional textures, procedural textures from Maya, in order to create more interesting curvature and bumps for the surface of this microscopic type world. All right, but as you well know, rendering a final image like this one is never the final stage of the production process. Usually you will continue with the post-production color grading and other post processes afterwards. And it's always great to preview your color corrections in the frame buffer directly, even while you're rendering. And you can easily do that in VRAY using the color corrections, which have been updated a lot in the new version of VRAY as well. So before you had like curves, exposure, and levels, and that was it. In VRAY 3, you actually have access to white balance, hue saturation, color balance, which I really enjoy, so I can change the color curves. I can also affect only the shadows or only the highlights of my composition and work from there. Of course, you can always still use the curves and so on. All of the properties here can actually be saved as presets, or you can save a global preset for the whole thing. On top of that, you have the ability to create your color grading or color corrections in Nuke or other post-production application, export them as cube, LUT lookup table files, and load them in the VRAY frame buffer. In VRAY 3, users can also use the OpenColor.io file, which is an open standard for color corrections, load it here in the frame buffer, and preview their final color grading. This one will also work when you use VRAY RT, so you can have interactivity with final color corrections. And you well know that one of the strengths of VRAY was the ability to output multi-channel EXR images. This way, everyone was capable of exporting all the render elements, all the data he needs in a single multi-channel file, and after that you got access to all the channels inside of Nuke, so you can do really sophisticated compositing. In VRAY 3 we have added we have improvement in that regard as well. So now we support EXR2 files which can hold the RGB data, they can have the layers included, and on top of that you have a deep data. So let me quickly show you a deep image rendered in VRAY, and I'll show you that in Nuke. So it will take a second for Nuke to load. And here it goes. That's the same composition. And I want to display the other viewer. This one here looks similar to what you saw inside of Maya, but that's not the actual image. That's a point cloud generated thanks to the deep EXR which was rendered. This means that I can actually select this point cloud, start rotating my camera, and explore its properties in 3D space, which is rather cool. You no longer have to render point position passes, normal passes, do some like slow and complex operations here in Nuke in order to get the point cloud. You get it out of the box. And this opens up for really cool possibilities afterwards. For example, I can start doing color corrections in depth. Just as an example, I'll move my blue tint towards the camera or further away. And I'll never have problems with the anti-aliasing because of the nature of the deep file format and the way in which VRAY is saving the data. So here's another example of deep color corrections. You can also add actual objects in the set and intersect them with the deep pixel information. So let me move that green screen towards the camera or away from the camera. And in another example, I actually rendered an additional virus. I wanted to add this one to the others. I can actually intersect it with the ground, move it around, and it will seamlessly fit in my set. All right. And on top of that, you can always convert your deep image to a regular image. You will have access to all the layers that you're used to seeing in Nuke. And as a bonus, for free, you will get the deep data that can be used for the Z defocus node inside of Nuke. All right, so I talked about the deep images, and those are, of course, not all the open standards that we support in VRAY 3. On top of everything that you already saw, we have a full support for the Alembic files, which is extremely cool. For example, if you export an Alembic file or the Alembic geometry particles here, whatever you decide to, save it on your computer hard drive, then you can always load it in Maya with the ABC loader. But with VRAY, you can also create a VRAY proxy loader and load the Alembic file as a VRAY proxy geometry. And it will have all the properties of a VRAY proxy geometry as a result. This means that I can load all the Alembic caches, and after that I'll be rendering them in the most optimized way possible, because that's the idea of the VRAY proxy loader. We have a full support for open subdivisions as well. They're added as object properties. So if I go back to Maya, select the geometry, I can go to attributes, VRAY, and add the open subdivision attributes to this particular one. And you have to keep in mind that creasing and other features of the open subdiv are also available and fully supported. All right, we of course support PTEX, also ODIM type textures and UV tile texture tags are fully supported with VRAY. They automatically work through the Maya file loader. All right, but one of the biggest focuses we had in VRAY 3 was the character rendering. And the rendering characters is like one of the most challenging things in the VFX industry, because it characters means rendering displacement, millions of polygons, ray tracing the subsurface scatter effect, which is like hundreds of light bounces in the material itself. Also, this means hair rendering, which leads to tracing the light information in between all the individual hair strands, and all of those effects are rather expensive and slow to render. That's why in VRAY 3 we have improved all of those. Let me show you some examples. So when we talk about displacement, VRAY is already famous for its quick and efficient way of rendering displacement maps. And we're also supporting vector displacements. But now in VRAY 3 we have improved the vector displacement support quite a bit. You can see this simple geometry clearly visible. That's what it looks like rendered. Let me resize the window. And I will enable a displacement for this one and change the material just for the looks of it. If I scroll down to the displacement options, you will see that vector displacement is available, but we have added two new options. One of them is the absolute vector displacement, and the other one is the object space vector displacement. And I'm using the last one in my particular example. The displacement map was exported from Mudbox, and when VRAY calculates the surface, that's the effect you can get with a single click. You can clearly see how fast and efficient VRAY is at rendering those extremely highly detailed surfaces. Also, you have to keep in mind that the displacement map is more than 8,000 pixels big, and still the performance is quite impressive. You probably noticed that the displacement took a while, or the renderer took a while before it showed us the image. The reason for that was VRAY had to load the texture in the memory of my computer before it creates the surface. And it took a while. If I had to do a lot of test renders one after the other, I'll have to wait every time VRAY loads the textures. And that's the reason, in order to speed up this process, we added a new option in VRAY 3 called cache bitmaps between renders and cache geometry between renders. When you activate both of those, VRAY will save everything that's in RAM for future use. And if I click the render button once again, I'll no longer have to wait. The render process will start right away. And in case you need that, you can clear the bitmap cache at any time. All right, to go back to the vector displacement, you can use the object space mode in order to create interesting effects like morphing one surface to the other, like I did here in my example. If the same effect is animated, you can easily achieve something like that. Here I have animated the amount of the displacement as well as the material blend. And I'm morphing this simple shape to this complex alien head. So here's another example of that. All right. All right, and now let's talk a little bit about skin shading. As you well know, VRAY had in VRAY, you already had access to the VRAY Fast SSS material, which was great because it was able to calculate the subsurface scattering effect rather quickly in a really optimized way. But it had a couple of issues. First of all, because it requires a pre-pass before the actual rendering starts, sometimes it will lose some of the small details of the surface, like some of the small bumps and really thin parts of the surface will not get enough information. The pre-pass is actually creating samples here and there, and after that it's interpolating between the samples. That's why VRAY is sometimes missing the small details. On top of that, you could never render the material in real time, like interactively, because the VRAY RT cannot handle pre-passes. The pre-passes are an issue. That's why in VRAY 3 we wanted to improve on that, and we added a new mode to the material called the ray traced mode. So let me save this image. I can actually dock the history to the frame buffer. That's another new feature. And I'll save the image for comparison's sake, and then I'll render with the ray traced mode activated. Okay, and out of the box, without changing anything else, I get a much better result, a much more detailed result. The reason for that, the ray traced mode uses sort of a brute force algorithms in order to calculate the subsurface scattering effect. So it's not relying on a pre-pass. This means that it will capture all the small details and it will do all the light bounces inside the material that are necessary. All right, when I compare the two images, you will see just changing the mode improves the quality of my image quite a bit. On top of that, since this one doesn't require a pre-pass, I can render it in real time. So let's start VRAY RT. Oops, sorry for that. I have to disable the default material because it will overwrite my skin material. And then enable RT. And here it goes. Interactive rendering of the skin shader. I can, of course, always change the colors and different properties of the material, and the image here in my Maya viewport will respond right away. And if that's not enough, in the new version of VRAY, we have added yet another new material that can help you create skin shading. If I want to assign a new material to this one, and I'll zoom in, you will see the VRAY skin material in the list. It's a brand new shader. Of course, it has the ray traced mode, so it's fully supported in real time. And the cool thing about it is it has multiple layers. So there's a layer for the diffuse lighting. You have shallow scattering, medium scattering layer, and deep scattering layers. All of those can be textured, and you also have amount and radiuses to play around with. Usually, you will specify your texture, color texture, in the shallow scattering slot. And also you'll specify a really small shallow scattering radius. After that, you will have the deep scattering layer used for veins or for really deep skin tissues. And the middle scattering layer will go somewhere in the middle. It will be representing like the fat tissue or the really shallow veins underneath the skin. So let me enable that and change its radius a little bit. And rather quickly, we get this really cool effect. Also, I have oftentimes seen people use the VRAY subsurface scattering material together with the VRAY blend material just to add multiple reflection layers one on top of the other. You'll no longer have to do that with the VRAY skin material because you have access to two reflection layers. So I have primary and secondary reflections. One of those can be a sharper reflection. The second one can be a blurrier reflection. And this way you can create an interesting effects for the skin of your characters. All right, and in the official version of VRAY 3 for Maya, this material is not actually supported on the GPU, but to tell you a secret, we have some new developments, and soon enough there will be an update as a service pack or a free update of our software that will support skin shading when you use the GPU for rendering as well. All right, and the last component of the character rendering process is the hair rendering, as I mentioned. And since our time here is limited, I want to show you two images that I rendered before the presentation. Actually, this is the first one. So here's an example of a Maya hair rendered with VRAY 2.4. And here's the same exact image rendered, oops, sorry for that. The same exact image rendered with VRAY 3. So we get 6 minutes compared to 2 minutes and 10 seconds. So the speed difference is rather big. Of course, all the speed changes, all the performance boosts that I was talking about are affecting the hair rendering, but on top of that, we have done a lot of specific optimizations of the code, specifically built for rendering hair and fur. And of course, it doesn't matter if you use Maya Hair or if you use plugins like Yeti or Hair Farm or Natrix in 3ds Max in order to create and style the hair. The speed boost will be true for all those cases. You can also use the XGen capabilities of Maya in order to create and style the hair. All the XGen tools available are fully supported by the new version of VRAY. Right, so here I have a hair styled with the XGen tools. I can click render, and in a second after VRAY loads the hair geometry, creates the hair geometry and loads it in the memory, you will see the frame buffer. And it's obvious that everything is rendered just fine. And of course, if you want to create a realistic shading for your hair, you have to use the VRAY hair material for the purpose, because it gives you all the necessary tools. It gives you all the layers, the backlighting, all the speculars that you need. In VRAY 3, we have improved the VRAY hair shader. It looks better. It distributes the light in a better way. And also, if you use the VRAY hair sampler texture in order to shade the hair or texture the hair, this one has been improved quite a bit as well. We have added some random parameters and some other attributes that can be extremely, extremely useful. Another way of using the XGen tools in Maya is to instance objects. So I can style hair, but I can also create instances. Of course, this functionality can be rendered in a great way. In this particular example, I have those island geometries. And I scattered some houses and some trees around using the XGen tools. In order to distribute different properties in between the houses, I have created different custom attributes. Like, for example, I have a random number, float number, between 0 and 1, which is then used for shading purposes inside of VRAY. This is just to show you that everything that can be done and that can be exported from XGen can actually be used for shading purposes afterwards in VRAY. And we have a specific team of developers who are responsible for that support. So here I'm distributing random colors for the rooftops of the houses and also for all the trees visible. Again, keep in mind that I'm rendering with all blurry reflections, full global illumination. I also have environment fog, all the production effects you would usually use in your everyday work. And still the performance is rather impressive. All right, I have to also mention that Bifrost is also fully supported in the new version of VRAY. All the data that the Bifrost solver exports can also be loaded in the VRAY materials and can be used for shading purposes. For example, if I have a Bifrost liquid simulation, I can always extract the vorticity or the velocity information for the liquid, and after that blend between different materials for the water surface and for the foam. That will all work just fine. And unfortunately, we're running out of time, and I had a lot more features to show you. So we have something called like the render mask. That's a tool that lets you render only the selected objects in the set. We have trace set, so now in VRAY 3 you can link, do reflection linking, and have one object be reflected by the ground plane, for example, but another one not. We have the maximum ray intensity. That's a cool feature that fixes fireflies and other artifacts of the rendered images, probabilistic lights for rendering thousands of lights, and different textures, different tools, a lot more options than I was able to show you today. If you want to find out more about those, you should certainly go to our new website, that is v-ray.com. If you write down /Maya, you will get the Maya specific section. You'll be able to see that. And in there, we have most of the new features listed. And in each one of those sections, you will get some videos and some additional information about how the feature is used and what the benefits of having that are. And you also have to keep in mind that with VRAY 3 we are updating the documentation. Like the help index of VRAY is much better. The installer of our software is better. Like we have the new website, and we're hoping to build a new community around this new website. As a whole, not only the software will change and will be updated, but we want to update the whole user experience. We want to make your life easier and more pleasurable. All right. All right, guys. So I think that was everything that that I wanted to show you. And now we have some time for questions. I'll try to answer as many questions as possible. So if you want me to add something, or if you are interested in something, just write in chat or in the questions section, and I'll make sure to answer those. So there is a question. What is my computer configuration? I can actually show you the CPU that I'm using. So I'm using 6 physical cores, 12 threads, and I have 12 gigs of RAM. But it's a regular computer that you can actually have in the office and use. I have a really powerful GPU, in fact, and that's why the GPU rendering was going that quickly. So there we go. I have 2 graphic devices. One of them is a GeForce GTX 770 card, which is used for the My interface and for Windows. And for rendering, I'm using a Tesla K40, probably the most powerful GPU available right now. So there is a question. How did you dock the VFB history? So in VRAY 3, that's a built-in feature. You just So let me show you that. So you just enable the history section, and then in the options you have the option dock history. I can do the same thing with the other windows. For example, if I enable my color corrections, I can dock the color corrections and have both of those available on the left and on the right side, which is rather cool. So there's a suggestion, if I can show the spherical harmonics mode of the GI. That's actually a long topic, so I'm afraid I'll not be able to do it right now, but we have a really detailed documentation on that. We actually have a step-by-step guide on how to set it up and use it. You should certainly go online, check that out. There's a question, what's the other subsurface scattering method that you saw? So let me, wow. Okay, so I'll quickly restart mine and show you that. So there is the prepass-based mode of the subsurface scattering material, which is the object space prepass. This means that VRAY will create subsurface samples which are located in world space. They'll have XYZ coordinates. The second mode is the ray trace mode, which means that VRAY will create no prepass whatsoever. And the third one that you probably saw was something called object space map, object space prepass. This one will again create samples before the actual rendering starts, but those samples will be created on the surface itself. So if I assign a new material, so let me add the VRAY subsurface scattering material. And here we have a prepass-based illumination map. This is the world space illumination map. And we have object-based illumination map. So this one will try to place the samples on top of the object itself. All right. And this one can be useful if the object is moving, for example. Then you can use this one instead of the old one. And the map will be much more stable and it will flicker less when the object moves. All right, let's see. So there's a question, which is better between CPU and GPU CUDA version of VRAY, of the VRAY RT renderer. And there are some computer specs. There's no better engine. Everything depends on your hardware. So if you have already invested in a CPU, in a really powerful CPU, then the CPU is better. If you intend, or if you already have invested in a powerful GPU, then you can think of the GPU solution. Now it hardly has any limitations. So for most production pipelines, you can even use it for rendering the final frame. And a lot of people have been asking me, well, how do you render animations using RT if you want to use it for production purposes? The answer is you can go to the RT options. You can specify maximum render time or maximum paths per pixel. This way you're limiting the render process for the particular frame. And then you can use the button called Render Animation with VRAY RT. This will render all the consecutive frames using the real-time engine, and you can use the GPU for final frame rendering. So in case you're wondering whether it's better to use the professional cards, like the Quadro cards and the Tesla cards by NVIDIA, or the gaming cards, the truth is, when it comes to performance, the CUDA cores are the important part. This means if you have more CUDA cores, the rendering will go faster. And some of the gaming cards have a lot of CUDA cores. This means you can get really nice performance out of those. And the GTX 770 is a good example of that. the difference between this one and the Quadro or the Tesla is that the gaming cards are not that stable, so they can overheat, and that's something the guys from NVIDIA told me. So they will always recommend the Quadro cards because they have been tested. They have better cooling, and in general, they are much more stable for longer use. So there is a question about a particular workflow, Grant Warwick's workflow, which suggests that you should put your samples of materials, lights, and all the other effects in VRAY up to 220. And the question is why that seems to be slower in VRAY 3. So I'm not 100% familiar with the workflow, but I can give you a hint. So in VRAY 3, we have added a new option, which is called minimum shading rate. And this is a simple slider that will tell VRAY to trace more primary rays or more secondary rays. What do I mean by that? If I specify a minimum shading rate of 1, VRAY will try to shoot more rays from the camera, like use more image sampler rays, compared to the secondary rays for materials, lights, and so on. If you increase the value to something, let's say 4, 10, 12, or even higher than that, VRAY will replace some of the camera samples with material and light samples. So VRAY will be tracing more secondary rays. And by default, this option is set to 2, which is not the case with VRAY 2.4. And if your secondary subdivisions are rather high, that might be the reason for the slowdown. If you want to have VRAY 3 behave exactly the same way as VRAY 2, you should specify a minimum shading rate of 1. If you want to take advantage of the new features in VRAY 3, you should probably consider altering the workflow a little bit in order to for it to meet your needs. So there is a question, will this be available anywhere else? I'm not sure what you mean, to be honest. Oh, yeah, not 100% sure. I'm not 100% sure. I know it's being recorded, but if it will be available online, I don't know. But we will have presentations of VRAY 3 available online for sure, and you'll be able to view those. It might not be the exact same webinar, but still you'll be able to see all the new features. So there's a question: how does it work with Bifrost? And I'll try to do this real quick. If you have used Bifrost, you probably know that it comes with a built-in material. So here's a Bifrost simulation that I did. You get the Bifrost material, and it has multiple layers. It has some control over the shading of the liquid, and VRAY users can use the Bifrost material, so it is supported. But in render time, VRAY is getting the data from the Bifrost material, and it's converting it to a VRAY material. On the other hand, if you want to do that manually, if you don't want to rely on the software to do the conversion for you, you can actually build material from scratch. Like in my particular case, I have built a VRAY blend material in which I'm plugging in 2 shaders. The first shader is for the foam, so it's a white material for the foam of the liquid, and the second one is the transparent material of the water. And I'm blending between the 2 materials based on a color set. And the color set is automatically created by the Bifrost simulation. you'll have two color sets. One of them is liquid vorticity, the other one is liquid velocity. You can extract the velocity data, for example, and use that easily in VRAY. In case you're wondering, if you want to load a vertex color data with VRAY, you have to use the VRAY vertex color node. So let's see. So here is the VRAY vertex colors node. This one will let you extract the vertex color data, and after that you can feed it in the shader. In my particular case, I'm using that for blending, for blend amount between the foam and the water material. As a result, I had that rendered somewhere. So let me find it. Here it is. As a result, here's actually the vorticity, the velocity, sorry. As a result, I have a material for the foam and material for the water, and I'm combining both those materials for the final result. You can also use the data for masks or for the post-production stage, all right? So there's a question, can you scale the rectangular lights, or do you still have to use the U and V sliders? It was always possible to scale the rectangular lights. Like if I unlock that, you could always scale the rectangular lights, but the problem with scaling is that if I changed my units to watts and start scaling the light, this will mess up the intensity of the light, because VRAY will multiply the intensity by the scale of the light source. That's why we're always recommending that you use the U and V size. Otherwise, you can scale the light, but then you have to compensate with the intensity multiplier. The reason for that is all the VRAY lights are based on physical reality, and in the real world, the size of the light will actually affect the intensity of the light coming from it, and that's why you get that behavior. On the other hand, if you use watts and just play with the U and V size, VRAY will keep a constant intensity while changing the softness of the shadow based on the size of the light source. So those are the two options. On the other hand, in VRAY 3 we have added a new option called toggle target. So if you enable that, VRAY will automatically create a target that you can position. I can rotate my light around the target and always disable that. All right. Okay, what else? So there's a question, how do you add the contribution of the global illumination to the VRAY light select? The answer is, it is added by default, but only on the GPU, only if you use VRAY RT GPU. It's still not a feature available for the production renderer. So that's why I showed you the feature with the GPU engine. All right. So there's a question, how do you use the new BRDF called GGX? So if I throw in a VRAY material here, yeah, you will see the new GGX BRDF. There's no special way of using that. Of course, in order to see an effect from the BRDF, you have to have reflections, and the reflections have to be blurry. And then the BRDF type will affect the cone of rays responsible for the blurry reflections. The GGX is just another way of calculating the effect. So you have to just try it out on your own and see if you like it. In fact, we're improving on that new mode quite a bit, and soon enough we'll be releasing some videos showing different examples of the GGX in action. All right, I'm looking for new questions. I don't think there are any. Yep, so there's a question, how do you use the UDIM shaders? There are a couple of ways of loading UDIM textures. Let me try and show you that. All right, as you well know, the basic workflow with the UDIM textures, UDIM texture tag, is that you will lay out your objects, create the UVs for your objects like so. So each part each part of your model will actually have UVs in an individual UV square. Like the first one has UVs from 0 to 1, the second one from 1 to 2, the third one from 2 to 3. Afterwards, softwares like Mudbox or the Foundry's Mari will let you paint textures on all the UV tiles at the same time. And then you can export each individual tile in a separate file on your hard drive. At the end of the day, you will have like 20 textures for a single geometry or single group of objects, and you need a way in order to apply that. So in VRAY, in order to apply it, you just create a single file loader, like so. That's just a single file loader. You load one of the textures, like the texture called 1001, and then you replace the number with the UDIM tag. So I'll write the sharp brackets, and in them I'll write down UDIM. Afterwards, VRAY will know that it should look for UDIM tiles on the hard drive, and it will apply the corresponding texture to each individual object. And when I render, you will see that the first cube will get the texture that says UDIM 1001. This one will get the second one, and this one will get the third texture. There's also a way to use the UV tile tag. In that particular case, you just have to write down UV tile instead of UDIM. And there's a third way. You can actually create custom tags. Like in my particular case, I have called this tag a texture tag. And I'm writing down texture tag in the brackets, right, for these middle cubes. But the effect at the end of the day is exactly the same. Yeah, so the multi-projection is similar to the projection workflow in Maya, but you have to test it out, see if it works for you. So you can actually have multiple textures and project them with multiple cameras. Also, it supports ZDepth textures. And it supports how many textures you need for your particular project. And that's with one single shading node. All right. What else? So any more questions? All right, so I think we'll stop here, guys. I have to thank everyone for the attention. I have to thank you for the big interest. I hope that everything that you saw was useful, and I hope that you'll try the new version of VRAY and that you'll enjoy it. And also, I hope I was able to answer at least some of your questions, and that the answers were okay for you. So yeah, thanks again, and thank you for watching.